Welcome to the IGVC's Self-Drive Sprint1 review presented by the cadets below. This is our Sprint1 goal, which is to understand the existing abilities of RTK, the abilities of Anvil software, determine what hardware we plan to use, and successfully turn in final design to Tardec. This slide shows our Sprint1 scope with our expected hours calculation, which we calculated by combining 3.5 hours with the number of cadets with the number of lessons in the sprint, which came out to 168 hours. However, our group completed 178 hours of work, which is 10 hours over our expected 168 hours. Now, Cadet Mary Pollen will go into the sprint backlog.
At the beginning of this sprint, we decided on the best way for our group to organize our Trello board to be most effective. We decided to organize our sprint backlog by overarching do-out, so there's a sprint backlog item that labels the start of all the required items to complete that do-out. 1 to 2 cadets are assigned to primarily work on each sprint backlog item within a do-out. At the end of each do-out, we have a sprint backlog item for one cadet to review the work and then turn it in. By organizing our Trello board in this way, we are able to clearly see which items are necessary for each do-out. The sprint backlog items for this sprint focused on preparing the necessary products for our upcoming PDR, such as the morph chart and the functional decomposition diagram, as well as creating the problem statement and requirement specification document for projects with hardware. We also were introduced to the Anvil simulation software and RTK during a lesson from Tardec representatives and follow-up communication with them. Finally, we began working with our LiDAR sensor to get data and begin understanding how to utilize the output. During this sprint, we also added important links and documents to the Resources tab of our Trello board. This will be helpful moving forward in the project so that we can quickly access frequently used documents. Finally, we worked on expanding our product backlog to reflect the specific requirements of the vehicle for the competition, as well as the do-outs for both our instructors and the client. During this sprint, we improved on our usage of inputting hours into the Trello board. Especially at the beginning of the sprint, we were consistent with inputting our hours directly after working on the project. Although our burndown progress plateaued a bit during the middle of the sprint, overall we had a fairly consistent burndown of work and ultimately exceeded our expected hours for a final scope of 1.06. Next, Cadet Norman will describe the progress we made working with the Velodyne LiDAR sensor.
During the sprint, we got our Velodyne HDL64E LiDAR operational. We used the provided GUI, VeloView, to connect to the Velodyne LiDAR. Once we had connected the LiDAR to the GUI, we were able to stream the sensor data to the interface where we saw the output of the sensor data as a 3D point cloud. We gained useful information from our initial test. We were able to verify that placing the LiDAR on the roof of the GEM E2 vehicle is the best placement for the sensor, as it allows us to build the most detailed 3D point cloud. Moving forward, we will work with ROS, Robot Operating System, to interface with the LiDAR and RViz. We will also look to see the sensor messages moving between the LiDAR and our computer, as these are the messages we will be using to identify obstacles within our environment. Next, Cadet Gingler will be discussing our in-house RTK lessons, RTK local access, and our Anvil simulation software.
We were fortunate to have Jack and Will from Tardec come out to teach us how RTK works and how to run RTK on a Linux computer to drive a simulation vehicle on a Windows computer using Anvil. We took video of the instruction for future reference, and we have communicated back and forth with Will and Jack to be able to install RTK and acquire a set of instructions for downloading and installing Anvil with the proper packages. Currently, we have RTK installed and built, and we have Anvil installed, but need to add the correct packages and link the computers. During the next sprint, we plan to have a running simulation with limited functionality.
After working with Jack and Will from Tardec, we were able to get RTK installed in the code folder. In order to build it, I had to edit a config file for ROS, and then go into the code folder and do a catkin build of RTK. It went through all of the necessary builds, and as you can see here at the bottom, it finished with all 196 packages succeeding. From there, we can go in and we can see that there are now all of these different packages it used to build, and then once it was built, we can go into source and see that we have RTK built.
The main takeaways from the RTK lessons are that RTK exists in a form that will navigate between points and around obstacles. we need to add specific features to adjust the cost map to achieve the driving behavior we desire. We also learned where the documentation exists for RTK and began to look through it and write up our own simplified notes to further explain the code. This will allow for a simpler and wider understanding across our team. Cadet Gaspari will now cover our morph chart, decision matrix, and proposed solution.
This morph chart is basically a menu of all different hardware decisions we need to make, including everything from sensor alternatives to how the computer will be mounted in the vehicle. This decision matrix is where the QFD meets the alternatives. The previously determined weights in conjunction with predictions about each design are used to create a score for each alternative. The middle of the road alternative received the highest score. We recommend the middle of the road design that utilizes a good combination of on-hand in-house components and purchased components to come to the best combination of computing and sensors capabilities with cost. I will be followed by Cadet Norman discussing the IGVC teleconference.
During the teleconference with TARDEC on 23 October 2018, we, along with several other universities being sponsored by TARDEC, discussed access to RTK, the upcoming deliverables, specifically the monthly report template, as well as the concept design, which is due on 01 December 2018, a quick progress update from each university, and scheduled our next teleconference. During this teleconference, the only team members present were myself and Mary Poland because the conference was not held during normal class hours. However, the next conference is scheduled for 13 November 2018 during our class period. A client memo summarizing the teleconference was sent out to the advisors and the entire team to inform the team on the contents of the teleconference. Next, Cadet Calderon will be assessing our sprint goal achievement.
We mostly achieved our sprint goal. We better understand the existing abilities of RTK and Anvil through the lessons and follow-up guidance from TARDEC. We determined what hardware we plan to use using a deck mat and even began setting up and communicating with the LiDAR. We have not turned in the final design to TARDEC, but we did receive clarification in our telecon. We worked on a preliminary design report draft that is being reviewed by our advisors and determined a new due date. Next, Cadet Maxwell will talk about recommendations moving forward.
Going forward, we need to consistently add hours worked, assign job roles, and specify turn-in standards in Trello. Our Sprint2 goal is to have the RTK Anvil simulation software fully functioning on 2 computers and create basic parking functionality, along with understanding what needs to be done to establish lane recognition on the cost map and interface the RTK code with the GEM E2. Our preliminary Sprint2 tasks are to finish the concept design technical report, which is due to TARDEC December 1st, install Anvil software on the second lab computer, and gain an understanding on how to use the LiDAR data. Next, I will be followed by Cadet Collier, who will talk about the product roadmap.
The product roadmap gives a brief overview of the project team's schedule. The product roadmap is a living document that will change and be updated as the project team advances through the timeline. Our group has now completed Sprint1 and is beginning to plan and prep for Sprint2. Thank you for your time and attention. This completes our IGVC Sprint1 review.